We deal in geospatial science and technology research at Maynooth University, and quite simply we work with different data streams that are collated from satellite platforms, from airborne platforms and in situ. We work out methodologies and algorithms for merging those data streams, and we build information services and then try to architect decision support systems to help people make decisions. So we're involved in a number of research projects in the context of marine mapping and monitoring. One of those deals with seaweed mapping. So in seaweed mapping we adopt a classic geospatial approach where we start at the top of this data wedge model, collecting data, synoptic data from satellites. That tends to be quite coarse, so therefore we have to use drones that allow us to go into these intertidal areas, these very tight slivers along the coastline, and try and map out those seaweed patches. Another project that we've just completed is the decision support for oil spill management platform, and that has been funded by the Petroleum Infrastructure Programme, and that deals with a system that allows people to manage and respond to oil spills offshore. A third current project, which is probably the largest, is the SFI-sponsored iCrag Centre, mapping and monitoring slick features. These can be anthropogenic, arising from human activity, such as ships washing out the tanks, or indeed they can be natural, like seepage, oil seepage, or harmful algae blooms. I think what we have at the moment is data being collected by satellites, by airborne sensors, shipborne sensors, in situ sensor networks. And this presents us with a huge volume of data. And the big challenge for us is being able to take those data sets, merge them, fuse them, and transform them into useful information to help decision makers manage our marine resources.
A lot of the research that we carry out here at GMIT on whales and dolphins has been in offshore waters, where we would work in collaboration with the Marine Institute. What we do is go out and we carry out abundance and map the distribution of whales and dolphins which occur within Irish waters. We have 25 species of whales and dolphins or cetaceans recorded to date in Irish waters, and that's a very big number of species given that it's over a quarter of the total that's found around the world. So Irish waters are very important for whales and dolphins. The research that we carry out at GMIT has mainly focused on visual monitoring of whales and dolphins. So if we go out and we do passive acoustic monitoring, we could go on a vessel and we can tow a piece of equipment called a hydrophone behind the vessel. So by towing that through areas, we can do visual monitoring where we can pick up certain species. So the animals could be at depth and they could be vocalizing, and those hydrophones will allow us to detect that presence, and it gives us a whole different way to map distribution and abundance and presence of these animals. Then the second type that we use is static acoustic monitoring, and that's where we will have specific types of devices that we will go out and deploy in a specific area. And that is extremely important because it gives us information on cetaceans at those sites over a very long time period. In the future, it would be amazing if we could start to tap into real-time monitoring offshore, whereby we could be in here today and be able to look at a screen and see what is actually being detected in real time. That would really make offshore waters extremely accessible.
So at the geophysics section at DIAS, we work on problems associated with the Earth, overall Earth structure, how volcanoes work, how earthquakes work, and the coupling of the oceans to the solid Earth. What we have are clusters of stations along the west coast, and from those clusters of stations we're able to say what direction the ground vibrations are coming from. Imagine a cluster like this, it will hit, if the ground vibrations are coming this way, it'll hit this station first, this next, this next, this next, and then this next. So we're able to say, oh, that's coming from this direction. So we're able to look in 5-minute windows at where on the seafloor these pressurizations are the greatest and how they evolve in space and time using the ground vibration measurements on land. And essentially what that tells us is that tells us the parts of the seafloor that are most pressurized by the storms or the ocean wave activity that's generating this pressure on the seafloor. One of the aims of the study is to get baseline information on the seismicity or earthquakes that we have in the offshore region. We currently don't know the details of them, how big they are, how often they occur. So we're trying to understand how the systems work The reason that's important is that earthquakes can trigger possible landslides if you have unstable slopes in the offshore area, and those landslides in turn can break cables and in a worst case scenario generate small local tsunamis. There's a growing interest in the study of what's called Earth system science. That's the coupling of the atmosphere with the ocean and the coupling of the ocean with the solid Earth, instead of looking at each of them individually, to look at how the whole system works. And Ireland is in an ideal geographical location for looking at the coupling between the ocean and the solid Earth.